Hello, this is our second video on the ME4111 tutorial sheet. We're working on sheet 3 and we're currently looking at question 6. Thank you for the feedback on the first video on this. Unfortunately, when I was doing the notepad, the camera cannot be made any bigger. So what I've done here in this is I've written the equations into the PowerPoint slides. So obviously this is a slower process and it takes a bit longer to prep the slides for this. Anyway, we'll drive on and hopefully this will work well for you. Looking at question 6 now, we're looking at, again, we kind of got a structure that has a three-dimensional force acting on it, this force F here. And we're told that it's got a magnitude of 3 kilonewtons and we're given some info on the angles. So we have the angle alpha here, which is the angle it's making with the x-axis, the angle beta, which the force is making with the y-axis, and the angle gamma, which the force is making with the z-axis. And we're required to break F into its 3 components along the x, y, and z directions. Okay, and we're given the answer here to help us work through it. We're told to use the coordinate system provided, so we cannot change it. So I've summarized the info that we're given up here. We've got our magnitude of our force. Again, pay attention to the notation. So we've got 3 kilonewtons on that, and we're given info on 2 of the angles. So our starting position here is always with 3D forces, is to use this magnitude and unit vector. So in essence, what we're being asked for is what is the unit vector, which is the direction of this force. And if we get that, we simply multiply this unit vector by the magnitude of the force, which would be 3 kilonewtons. So what we're going to use is the fact that the unit vector is given by the cosine of the angles that the vector makes at the respective axes. So we have cos theta x in this case will be the angle alpha, cos theta y, which would be the angle beta, and cos theta z, which would be the angle gamma. Again, bear in mind, these are angles that are in the 3-dimensional space, so they're coming from the line of action of the force to the axis in question. Okay, so they're not confined to an xy plane, for example, or an xz plane or a yz plane. So obviously in this question, we're given beta, so we have cos theta y. We're given gamma, so we have cos theta z, but we're not given alpha. So we need somehow to figure that out. Now the easiest way to work out alpha is to note the fact that a unit vector has a magnitude of 1. All it is a direction. So if we take the magnitude of this, we'll have cos squared, the square root, the sum of the squares of these, the square root of all that is equal to 1. So we'll leave out the square root because 1 squared is equal to 1. So we have the sum of the squares of each of these terms is 1. So we have cos squared alpha plus cos squared beta plus cos squared gamma is equal to 1. And this allows us to solve for alpha because we have beta and gamma. So working through that, we simply rearrange and solve for alpha and get 64.6 degrees for that angle. Be careful when you're doing this that you don't forget that the cos term here is squared. So you need to take the square root of that and then do the inverse cosine. So it's quite common when students do this, that they leave in the cos squared alpha and do the inverse cosine of that. So you take the square root of that to get the 0.428 and get the 64.6 degrees out. So now that we have the 64.6 degrees here, we can plug in our equation back up here. That we have the 64.6 degrees here for cos theta x, which is the angle it's making with the x-axis. Cos theta y is our 30 degrees, and cos theta z is our 75 degrees. Okay, so we plug these numbers back in to our unit vector, and we get this as our unit vector. Okay, so cos of 64.6 comes out to be 0.429, cos of 30 is 0.866, and cos 75 is 0.259. Okay, and then going back up to this equation up here, we simply take that unit vector and multiply it by the magnitude of the force, which gives us our answer out. So we have the vector F expressed in its three components is 3 times the unit vector, which gives us 1.29 I hat plus 2.60 J hat plus 0.78 K hat. Okay, that concludes the video, and thank you for watching, and hopefully you found that clear enough and were able to see the workings. And again, I appreciate any feedback that you may have.